Prof, really appreciate you carving out some time today for us.
Oh, you're very welcome, Marc. I'm looking forward to speaking with you.
Well, listen, for anyone who might not be familiar, can you give us a little bit of a whirlwind tour of your background, and then we'll dive into all things immunology here today?
Okay, well, I've kind of worked in academia all my life, sort of a permanent student almost, if you like, a BSc, a PhD, and then several postdocs and that before I got a lectureship at Coventry University. The background's really been in diet and metabolism, the impact of exercise and different exercise on body metabolism. And then after hearing a lecture by the late Eric Newsholm, who was very big into one of the pioneers of exercise immunology, he sort of inspired me to sort of move my research into that field. And it's always good when you're an academic to get into a new field of work because you're ploughing the furrow, as it were, in that area, and there's lots to be found out. So I've done about 20 years of research on that particular topic over the years, and actually retired from academia, from university life, about 5 years ago. But I'm carrying on doing these sorts of podcasts, recorded lectures, still contributing to some consensus review articles, things like on probiotics and the UEFA expert group on nutrition for elite football, or soccer as they call it across the pond. Yeah.
Oh, tremendous. Yeah, looking forward to diving into those topics here today. Actually, a few years ago, got to the International Society of Exercise and Immunology conference out in Portugal, which was fascinating to see on the performance side and, of course, the health side. But as we move into winter now, and whether it's, soccer, as you mentioned, American football, basketball, it's great to see now that athlete health is more on the forefront than it had been in years and decades past. And, of course, the immune system is really an important piece of that. And I think COVID's obviously really shone a light on that. And so when we look at trying to support athlete immunity, I mean, to start with, what are the factors that can actually start to lower or depress immunity, for an athlete?
Yeah, well, there's probably about 6 main factors that can depress immunity in an athlete. And of course, any depression of immunity can mean an increased susceptibility to infection if the actual exposure to pathogens in your environment remains about the same. So with the athletes, I mean, probably the biggest one is the impact of the exercise they're doing. Performing prolonged, continuous training sessions, particularly if it's not with any nutrition taken on board, can depress immunity. And that effect is sort of amplified when the athletes do periods of intensified training where they kind of cut out the recovery days that might normally intersperse training days in their normal sort of microcycle. And that's when you start to get a real depression of immunity that you can measure kind of in the resting state, and it's still present at least 12 hours since the last exercise bout. So, it's sort of a progressive thing that's happening there. You get that with prolonged bouts of exercise and intensified training. But on top of that, you've also got psychological stress, which can also depress immunity. So worry, anxiety, depression, that can affect an athlete, the way results are going, how they're performing in training. Are they keeping their coach happy? Are they falling out with their teammates? There's a lot of stresses in there, not to mention the monetary ones, and the ones from the media and things. So, a lot of pressure and stress, therefore, psychologically as well as physically. And then you've got that, and also the exercise they do can impact on their sleep quality and their sleep quantity. So if they're getting less than 7 hours sleep per night and their sleep efficiency is, say, less than about 90%, that's going to increase their risk of picking up infections as well by depressing their immunity. If they have to exercise in environmental extremes, that's an added stressor. So, exercising extremes of heat or cold or altitude in particular adds to the stress of the exercise. Also, if there's a lack of sunlight like there is now in the winter months in the northern hemisphere, it means probably vitamin D is going to be insufficient unless they're supplementing, which we recommend for all athletes. And on top of that, you've got long haul travel going across 3 or more time zones, disrupts sleep, disrupts your body clock, and that impacts on immunity negatively as well. And then nutrition, deficiencies of energy, protein, certain micronutrients very important for immune function, like iron, zinc, vitamin D, etc. Those all can cause, depressed immunity as well. So, kind of lots of different things that can impact on that. We used to put it all down to exercise at one point when it all, intensified training. But there's now a realization that all these other factors come in and can be related or caused by some of this extra exercise that they're doing when they're training really hard.
Yeah, it's interesting when we get to this time of year as well with sort of the modern schedules, compressed schedules. So of all the things you mentioned, more than likely for a lot of athletes, all of those things are happening with sort of lack of sleep, and we're traveling and training might be more intense or prolonged. We have, the stresses of obviously the team that you mentioned. We also have the stresses at home, and just, of course, the social media of things adding a layer of stressor. And so if we maybe start with the vitamin D side of things, where are we at now in terms of testing vitamin D levels? Is there a certain level that's going to provide the most protection, or up to a certain point that we're going to see protection in terms of immunity?
Yeah, well, vitamin D status is usually measured by taking a blood sample and measuring the concentration of 25 hydroxy in the blood serum. That's derived from what's being produced in the liver, where that first hydroxylation of the vitamin D precursor molecule takes place. And that seems to give us a good measure. The concentration of that in nanomoles per litre gives us a good measure of vitamin D status. We have different classifications of it. So if it's less than 30, that's deficient. If it's less than 50, it's considered inadequate. And somewhere above 50 and up to about 150 is the desirable range to be in. For bone, certainly 50 is considered the adequate value. For immune function, it seems it's probably somewhat higher. So probably in excess of 100 would be desirable, and at least 75. Nothing below that, really. And studies that have actually measured various markers of immune function in athletes, some of which we did ourselves. When I was working at Loughborough in the labs there, we found that the best protection for the athlete against picking up infections and against getting more severe, longer lasting symptoms when they did get infected was with above 120 nanomoles per litre. Now, you don't want to go too high. You can only achieve that with regular exposure to sunlight or by taking vitamin D supplementation. And there is a limit that's suggested to be 4,000 international units per day. It's the maximum you should take to avoid going above 150 nanomoles per litre, which could potentially be harmful.
And is that why we potentially see more and more teams sort of heading off to warmer climates in the wintertime to, if we can only get to 4,000 IU really per day with supplementation, that's going to provide us some benefit, potentially going away for these small training camps to somewhere warm to be able to get that real exposure?
Well, I guess that helps, but you can achieve it just by supplementation.
Yeah,
and I mean probably 2,000 international units per day is what we recommend for athletes. That will ensure that they have levels that are in excess of at least 75 nanomoles per litre of that metabolite. So that's good. I think the going to the training camp is just sort of perhaps a psychological boost, a change of scene, a bit of nice warm sunshine, making the players or the athletes feel good.
And so in your opinion, I know a lot of teams will kind of get hung up on if someone's at 80 nanomoles or 90 nanomoles, trying to push them up to past 90 or towards 120. And then they might decide to go, rather than 4,000 IU, let's do 8,000 or 10,000 IU. Would you be advising against that type of, we've seen some adverse data on some of the downstream metabolites there?
Yeah, there have been some papers that suggest that's not desirable from a health perspective, and that observations that have been made on people who don't take supplements but who are living in sunny environments, your vitamin D concentration, the 25 hydroxy vitamin D in the blood, never goes above 150 because we regulate it. And we stop producing vitamin D in the body when we get to that level. So that's more or less telling you the body doesn't want to go above about 150, so don't do it with supplements.
Yeah, great point. And what about for athletes, Black athletes, Hispanic athletes? The normal ranges that we see aren't necessarily we don't have as much data on different populations, do we? So in your opinion, I mean, I know again, certain groups will have an athlete that has a level that's lower in terms of that quote unquote normal range, and they're really making big efforts to push that number up. And sometimes despite any real symptoms of the athlete, being immune depressed, catching colds and flus, struggling with any other sort of performance or recovery metric, but the fact that it is 20 or 25 nanomoles per liter in, let's say, a black athlete, then that becomes more cause for concern. Could you maybe comment on what the body of knowledge is around the different ethnicities?
Well, certainly from the measurements I've seen on some professional soccer players, they have a whole mixture of races within their squads. Quite often you can have Asian players, you can have Chinese players, as well as British players, European players, and players from Africa and the Caribbean as well. So yes, there's a whole mixture of skin colors in there. And the ones who are darker skinned, and particularly the black players, do tend to always have lower vitamin D status when they're first measured before any supplementation is given. But they're treated in the same way as the rest of the squad, and they take exactly the same supplements, and it just seems to bring them up to the same level as everybody else. So I mean, there's no real need for any special considerations there, other than that if you've just signed a new player to your team and he's a black guy, then you might want to test him for his vitamin D status and put him on supplementation if he's below 75.
Yeah, and just curious again on that point of if the athlete's levels stay around 25 or 30 and don't budge with the 4,000 IU. I mean, I think this is a scenario that's been presented to me a few times, and then oftentimes the staffs will go into mega dosing or things like that in an effort to try to push that number up. Again, just sort of curious your thoughts there on strategies, or if that's
It has been done. In fact, up to a few years ago, I know one football club that I've worked with a few times were using mega doses, like 100,000 units, and just giving that on a monthly basis.
Yeah.
I mean, the trouble with these professional athletes and football players, soccer players, they're taking often quite a number of different supplements. And adding a vitamin D tablet every day is just another tablet they've got to take in that. In that
compliance, right?
So compliance can be an issue, and so that was one way they thought of getting around it, until the more recent studies that have come out that suggested that perhaps that's not a good idea. I mean, in reality, in the world of medicine and patients dealing with people with bone diseases, for example, and frank vitamin D insufficiency, really deficient levels, they are often actually put on these mega doses, but that's done under medical supervision. So I guess that's the proviso. May be considered giving higher doses, but only for a limited time and under medical supervision.
Yeah, great point. And if we look at some of the other nutrients, obviously you touched on the intensity of training and carbohydrate playing a key factor. I think this is one now in, let's say, the general population. So many people are adopting lower carb diets. So sometimes the athlete's friend or brother or sister or someone's adopting that diet, and they can sometimes trend that way. And now all of a sudden we're training more intensely or more prolonged. Can you walk us through some of the benefits there in terms of immune function when we do provide some carbohydrate?
Well, the carbohydrates just really needed to fuel the exercise, because if you're doing any activity that's going to tax you above 60% of your aerobic capacity, the fuel your body is going to use mostly is going to be carbs.
Yep.
So you need it for that reason, for glycogen. We know if you start a soccer game with low glycogen levels, you're fatiguing by half time, and you've almost run out of glycogen in your muscles by half time, and that impacts on your performance, particularly in the second half of the game. So you need it for that reason. If your blood glucose levels drop, that tends not to happen so much in football, even if you didn't take on board any carbohydrate during the game in the form of drinks or gels. Your blood glucose levels stay fairly stable. If you were to perform a sort of more prolonged exercise, and that, like running a marathon, for example, then yes, your blood glucose levels will start to drop after about an hour and a half to 2 hours into the race if you don't take on board some carbs, and that can impact on immune function, because white blood cells use mixture of usually the amino acid glutamine and carbohydrate in the form of blood glucose to fuel themselves and perform their essential functions. So there's something there to be said for if your exercise you're going to do. It depends on your sport, in other words.
Yep.
If you're going to do very prolonged exercise, then by all means feed carbohydrate during the exercise for that purpose of stabilizing blood glucose, which reduces your stress hormone response, and that removes that extra stress on your immune system, which can depress it.
Tremendous. And when we think of protein, even a lot of athletes now are still just think of protein to do with muscles and less to do with immunity. Yeah. Can you walk us through? I mean, you mentioned glutamine there, amino acid. What's the importance of protein on immune function?
Well, protein is an essential nutrient for the immune cells, just as for many of the other cells in the body. And we know that if people have inadequate protein, their immune function will be, below par, let's say, or let's say it's going to be suboptimal. And that's what we're aiming for a lot of the time here, not just giving the minimum amount that will keep you adequate. You're aiming for what can be the best possible outcome for the individual. So if you want their immune function to be as good as it can be, you should be aiming for a protein intake of around 1.6 grams of protein per kilogram body mass per day, which is actually double the normal RDA for protein, that's recommended for the general population. In reality, most people eat more than that anyway, more than that 0.8 anyway.
Most athletes definitely
1.2, and athletes need to eat more because they also need to repair those muscles and adapt to the training after the exercise session, as well as maintaining their immune function as good as it can be.
Yeah, I mean, it's a great point to reiterate to athletes, because oftentimes if they get tired, all of a sudden that regular meal frequency that we have, we miss a meal here, or we don't get a recovery shake and carbohydrate. And so all of a sudden we're potentially lacking on some of the fueling, pre or during session. And now we missed some on the recovery window. So it's great to highlight the importance there. What about some of the other micronutrients, things like iron, zinc? What role are they playing in terms of immune function?
Probably the three most important minerals are probably like iron, zinc, like you say, and also selenium. Zinc probably, particularly important because we lose some zinc in sweat. We also use a little bit of iron in sweat, and iron status can be a problem potentially for female athletes in particular because of the menstrual blood losses. So the role that zinc plays is thought to be important because it's something that can actually inhibit viral adherence and replication inside your cells, because viruses damage us by getting inside the cells using our own machinery, if you like, to reproduce themselves, both their nucleic acids and proteins within the cell. And zinc interferes with their ability to do that actually by inhibiting the enzyme that allows them to replicate their RNA. So zinc can be quite effective for that. And studies show that if you take zinc lozenges at the onset of cold symptoms, it does reduce the duration of symptoms. And having adequate zinc will also, theoretically at least, reduce your risk of picking up some viral infections. To a degree, the same can be said for selenium. That's also a component of some important antioxidant enzymes which actually improve what we call immune tolerance. So we have immune tolerance, we have immune resistance, and those two things work hand in hand together simultaneously to help stop bacteria either getting into the body or viruses getting into the body and starting to multiply, or making sure we don't kind of overreact to the infection in terms of our immune response, which can also in itself cause tissue damage and therefore symptoms of illness.
Yeah, I was going to segue into that. It's a perfect transition there in terms of immune resistance, immune tolerance. People will be familiar with these terms, but can you circle back there and define those and explain to us how they work together to be able to balance out the immune system so we're responding appropriately to the infections?
Yeah, I mean, immune resistance is about being able to resist microorganisms like bacteria and viruses either getting into the body and gaining a foothold, or being able to kill them quite effectively and eliminate them once they have entered the body.
Mm-hmm.
So we normally respond to things once they've gotten into the body. We've got some first lines of defense, like the barriers, the mucus secretions and things like that, which help defend us against things. I mean, immune resistance essentially determines your susceptibility to picking up infections, whereas immune tolerance is more to do with how you handle the infection as it starts to develop. An important thing that we've realized from infections like COVID is that you don't want an overreactive pro-inflammatory response, because it just produces too much damage. You end up damaging your own tissues. In this case, of course, it's the lungs, because it gets into your airways and the lungs, this COVID virus. So that's something you want to be able to control the infection, but you don't want to overreact to it. And that's what causes this awful, acute respiratory distress syndrome. Then you don't get enough oxygen into your blood because your lungs are filling up with fluid. The barrier that allows oxygen to come across becomes too thick, and you really struggle then, to get enough oxygen into the body. Your blood oxygen levels drop, and then your other organs are then starting to run into trouble. Your heart, your liver, your kidneys, etc. So it's as we've seen, it's potentially fatal.
Yeah, I mean, when we talk high performance, we also think of obviously the coaching staff, the performance staff, and everybody else. And obviously, if you mentioned COVID in the last few years is where we're focused on and trying to obviously avoid it on the one hand, but it's difficult to avoid. So how well we respond to it and the severity of symptoms. And so with regards to something like immune tolerance, are there certain aspects of one's health, whether it's, weight, metabolic health, these types of things that can impact that immune tolerance and push us down, the certain side too heavily?
Yeah, I mean, the main things, and again, we've seen this from the COVID infections and the studies that have been done on the people who've had it. The ones who have the biggest problems are those with existing morbidities, that have type 2 diabetes or coronary heart disease or existing lung problems. Those are the ones who fare worst. And often it's also associated simply with being overweight. In other words, having too much, an excess of adipose tissue, because this generates a pro-inflammatory environment in the body. When your fat cells get too big, they get stretched and they kind of release danger molecules that are signaling that something's going wrong. The tissue's being stretched, it's potentially going to be damaged. But it's just because you're getting too much fat accumulating in these cells. When that happens, the body treats it like, it's a damaged tissue. So what do? You get white blood cells invading into the adipose tissue. They become activated. They produce pro-inflammatory cytokines, and these induce a pro-inflammatory state, which means if you get infected with something like COVID, then you're actually already primed for a very strong pro-inflammatory response. Awesome. And essentially that's when you get this over responsiveness of the immune system, which can be so damaging.
Yeah, it's amazing when that inflammatory noise gets to be so loud. And as you mentioned, you combine it with this type of infection, novel infection, then it can really cause problems, particularly in people with comorbidities and struggling with metabolic health. And obviously, as we've seen, the governments have really, rightfully so on the prevention side, whether it's the distancing, the masks, the travel mandates, etc. The other side of the coin with maintaining a robust immune system seems to be an area that we sort of missed out on, really, in terms of supporting the public in a sense of how do we help them have a better immune function with their fitness or diet or whatnot. Could you talk a little about nutrition or exercise, sleep for the general population or performance staff? I mean, even athletes, I guess, but for that general person, of how those things can help to support that robustness of your immune system.
Yeah, on the nutrition side, it's the most important thing really is to avoid any deficiencies in terms of protein that you consume, in terms of overall energy intake, which should really match your daily energy expenditure, so that you're in energy balance, and making sure you have all of those essential micronutrients that you need.
Yep.
Now, in addition to that, which can be obtained from eating a healthy, varied, balanced diet, of course, yep, you also get a very good, abundant and diverse gut microbiota, and that interacts a lot with the immune system. Like 70% of our immune system is located in and around the gut, which tells you there's something of importance going on there. And if you have a healthy gut microbiota, you can also help to support the immune system that way. I mean, one supplement that can perhaps help with that, and has been shown to reduce infection risk in athletes, as well as other things like allergies, is a daily intake of a probiotic supplement, essentially live bacteria that you're introducing into the gut, which mingle with your own bacteria. Some debate as to whether they actually colonize the gut, probably not to a significant extent, but they act as sort of signals which modify the immune cells in and around the gut, which can then diverge to other areas of the body, including the lungs, and other mucosal tissues, where most of our infections come in, either usually through what you've eaten or what you've breathed in. So that's on the diet side. Yep. And then, of course, there's the exercise. Well, it's good to do regular exercise because that actually induces an anti-inflammatory environment in the body through the release of things like anti-inflammatory cytokines, in terms of interleukin 6 or IL-6, which is actually released not from white blood cells, or it is released from white blood cells. It also released from contracting muscle fibers. Whenever you're doing prolonged exercise, because your glycogen levels go down, your IL-6 production and release from the muscle increases. That induces your white blood cells to produce interleukin 10, which is probably the most potent anti-inflammatory cytokine we know of. It burns fat, it reduces your fat stores, so it's bringing down that adipose tissue mass if you're a little bit overweight. It induces switching from pro-inflammatory to anti-inflammatory phenotypes of the white blood cells, both in the circulation and in the adipose tissue, reduces white blood cell infiltration into adipose tissue, which we just said generates some of these potential problems. And generally, if you do moderate exercise, you'll increase the numbers of white blood cells in your blood, but you won't actually inhibit their functions because you're not doing the intensities of exercise where you might actually get increased cortisol, stress hormone, epinephrine or adrenaline production, which tend to have negative effects temporarily on immune function. And then sleep as well, of course, getting good quality sleep and doing all the things you can do that to make sure you get a good night's sleep with very few interruptions. And that's really about creating the ideal environment for sleeping in your bedroom. There are several things.
Yeah, it's amazing how these days it's one of those simple but not easy in terms of the typical person getting about 6.5 hours of sleep, or 30%, I believe it is, and getting less than 6 hours. And so it's bringing that top of mind, isn't it, to say, okay, I'm going to need to start planning my sleep routine a little bit better to try to get to that minimum 7 hours.
That's kind of the average. But we have to appreciate everybody's a little bit different in terms of their habits. Some people are night owls, some are like early birds, aren't they? Depending on how you're made up. But and there are genetic differences as well. And some people can get by quite well on relatively few hours of sleep compared to others. And probably some evidence out there as well that also says you probably shouldn't sleep for too long either.
Sure. I mean, would you say that 7 hours minimum?
The happy medium between 7 and 8 hours is probably about the ideal for on average. But in a sense, it depends what your normal routine is. If you normally get by on 6 hours quite happily,
then 6.5 will feel great.
Then that's probably what's right for you, but don't go below that.
And just circling back to the exercise, obviously we see the benefits on the fitness side of things, and of course you alluded to there, like on the muscular side of things, the myokines, and of course with the fat cells, the adipokines. I mean, these are really sending powerful signals to the immune system, correct?
Yes, indeed. I mean, I think most of what's referred to as adipokines are the cytokines that are coming out of adipose tissue. They're probably mostly not coming actually from the fat cells themselves. They're actually coming from those white blood cells that have infiltrated those expanding fat stores. Yeah,
and if we keep talking about how to support people's health, if we mentioned some weight loss, better metabolic health, these are really crucial things for supporting immunity so people can perform their best at work and at home. You talk a little bit about HIIT training in terms of losing body fat might not be necessarily the best solution for getting leaner. Could you expand on that a little bit for us?
A couple of years ago, I read a couple of what we might call celebrity doctors or medics, people you see on the TV and hear on the radio and that kind of thing. Probably not yourself, of course, included here. Hopefully not. But yeah, I read a couple of books, and they seem to be promoting the idea that doing this high intensity interval training, or HIIT, was even better than moderate exercise for weight loss, for body fat loss. But if you look at it logically, it's complete nonsense. Because if you're doing a HIIT session, one book just recommended just doing 5 minutes a day to get this weight loss effect. Most people might do about 15 minutes of HIIT as a daily session, and that might be usually something like 6 30-second bouts of pretty much all-out exercise with 2 minutes recovery in between bouts. So in that 15 minutes of HIIT that you're doing, you're only doing actually 3 minutes of very high intensity exercise. Work out how many calories you burn doing that. It's about 100 kilocalories. You might burn another 100 due to the post-exercise elevation of resting metabolic rate, which could keep going for a number of hours. But even if it was increased by 10% for 12 hours after you did your exercise bout, which probably isn't actually, but that would only be another 100 calories. So doing that 15 minutes a day is only going to burn 200 calories. Most of that will actually be from carbohydrate because the exercise is so intense, and some of it will be anaerobic metabolism of your glycogen stores. You're not burning fat. You're still burning calories. So at the end of the day, when you tot up your calories, you've still got that energy deficit of 200, but it's not a lot. I mean, you can do that with just a 2-mile brisk walk or jog.
It's amazing how.
So by far the best way of burning calories is to expend more energy, and you only do that by doing prolonged, moderate intensity exercise that you can sustain literally for an hour or more. Then you're getting into the realms of burning, say, 500 calories an hour or something like that, and that's the thing that's going to make an impact on burning your fat. And if you're doing low to moderate intensity exercise, like brisk walking, jogging, cycling, but not too fast, then you're going to be burning mostly fat rather than carbohydrates. So you're directly burning those fat stores you want to get rid of.
It's such an interesting point, because I know that even in Dr. Martin Cabala's lab, they're just pushing the participants enough to achieve that real high intensity as they got fitter is a challenge as well, to just actually really be hitting some of those top ends. And as you mentioned, time-wise, I mean, we really need to start to not be forgetting about just building out an aerobic base and actually getting enough movement in. And it is interesting that just the amount of movement that we get in a day is sort of a better predictor of maintaining a weight than that, half an hour in the gym, if you will. Did you have any, suggestions or around building an aerobic base, or in terms of frequency or timing?
The HIIT thing. I'm not saying HIIT is bad for everything.
No, for sure.
It's actually a very good way of getting some of the health benefits of exercise,
time efficient,
without doing it time efficiently if you push for time. But I'm just saying it's not very good for weight loss, but for burning fat. That's the only proviso I'm putting in there, as opposed for, like, say, for doing regular exercise for health. I think we should really be doing a mixture of different modes, because you get benefits from doing some resistance exercise to help maintain your muscle mass, which of course declines as we get older. I'm 65 years old, and you start losing muscle from about the age of 30 to 40 onwards gradually. I know, unless you keep up with some resistance exercise. If you do that, you can help to maintain your muscle mass. That in turn helps to maintain your resting metabolic rate, because lean tissue is more metabolically active than your fat tissue, and that helps to keep the weight off as well. And if you want to diet and lose weight by reducing your calorie intake through eating and drinking less, then doing some exercise will help prevent that resting metabolic rate from falling, which it will otherwise. It'll drop by probably 10 to 15% within a matter of weeks. There's an energy conservation response. But if you do the exercise, that helps to offset that effect. So it makes your weight loss actually easier.
And
plus you're burning those extra calories. Of course,
there you go.
You're adding to your diet calorie deficit.
I was supporting clients, and we're always trying to teach them the principles of how the various diets work, rather than just having to select a singular diet. And understandably, for a lot of people, it's let's say easier to start with to have a certain diet because it's got a strict set of rules and it's sort of a path to follow. But what we tend to find eventually is it doesn't matter what diet people pick, they're going to end up with roadblocks. And if they don't understand some of the principles or the different tools at their disposal, then they don't know how to overcome the roadblocks. They don't have the tools. So can you talk a little bit about, you've written a book all around the different, having sort of the best of all the worlds really, or understanding these tools so that we can apply the right ones to help us lose weight in the long term.
Yeah, you're right. I mean, often people go with just one diet because that's, it's they pick a certain book or a certain article they've read in the media or in social media or whatever, that promotes a particular diet. Usually there's just a book is usually just about one diet, and it tells you all the pros of that, maybe not always telling you what some of the cons are maybe, but the problem with all single diets is you're usually restricted in eating certain foods to some degree all of the time, and it means you're then constrained to eating a certain number of different types of foods and you're excluding others. And then people start to get cravings for those things that they would normally include in their normal diet that they have to restrict on these, more specialized diets, whether you're talking about sort of a low carb keto diet, or at the other end of the spectrum, sort of a virtually zero fat diet and getting most of your energy from carb. You've got those two extremes. And at the end of the day, when you look at all the literature out there that's been done on the effectiveness of different diets, they're really, really not very different in terms of their efficacy for weight loss if you match them for the actual amount of calories that are being cut out from the normal diet. So if you have a 500 calorie a day deficit on a keto diet, you'll lose pretty much as much weight and as much body fat in the long run, over sort of several weeks and months, as you would if you had a high carb, low fat diet with the same daily energy deficit. So what I say is don't, generally avoid the extreme diet. You don't need these extremes of macronutrient composition. You don't need to get keto to lose weight, if you see what I mean.
Sure.
And you don't need to cut out all the fat from your diet to lose weight either. And that wouldn't be a healthy thing to do, actually, because we actually do have some essential fats,
soluble vitamins, right?
Yeah, linoleic acid, linolenic acid, etc. Those two are essential. You get your fat soluble vitamins, your A, D, E, and K with intake of fat. So we don't recommend ever cutting down your fat to less than about 10% of your total energy intake. You need a certain minimum there for health. So a sensible thing to do, I think, if it's probably about out there's probably 10 to 15 diets that have had plenty of work done on them, including the keto, but also including low fat and other ones like high protein, high fiber, volumetric diet, that kind of thing. Then you've got intermittent fasting diets, you've got time restricted eating.
Yeah.
There's loads of different ones, probably about 10 which are pretty much equally effective and proven to be effective. So my idea was just, why don't you just switch your diet every week? Now, it might sound complicated. That means I've got to switch all the rules every week. But if you actually know what you're doing for each of these diets, and that's why I kind of wrote that book, The Pick and Mix Diet, which is just that, all the meal recipes and amounts that you need are provided, so you can actually achieve your weight loss through just following those sorts of different recipes, and just do it for 1 week, and then you switch back to a different diet. You can do it in pretty much any order you want. If you're getting a bit of cravings for carbs because you've started off on your keto diet as the first one, or at least a reduced carb diet, you could go to the other opposite of the spectrum, and go for a high carb, low fat diet, and then maybe go on a high protein diet or go on a flexitarian diet. Some of the established diets we have that people eat around the world, like in Japan and around the original diets that they ate in the poor Mediterranean countries, are very healthy diets. And because you're not used to them, you tend to eat less anyway of them, and you you lose weight that way as well.
Yeah, I mean, it's a couple things come to mind there. I mean, you mentioned, yeah, once we match for protein and calories, then it really doesn't matter which diet we're picking. We've got to, get into that caloric deficit. And so it is great to have all these different tools, like you mentioned. And even for people, when we talk about them, just going through the process, right? They might go through, as you mentioned, the different diets and the pick and mix, like a low fat diet, knowing that hey, maybe I don't want to follow this forever, but they tend to pick out a few skills within that week or recipes or things that they enjoy that then end up really helping them down the road with, whatever pattern that they do prefer. So I definitely think that's a great process for people to go through.
And if you sort of measure your body mass just, once a week, at the start and end of that week, you've been on a particular diet, you also get an idea of which ones of those diets will actually work best for you. And also which ones gives you the sort of combination of foods that you enjoy the most. So at the end of the day, if you were to do dieting, you might do that for say 10 weeks, in which case you could lose about maybe 10 kilos using this kind of approach, particularly if you couple it with doing some exercise to add in there and burn some calories as well as taking in less in what you eat. Combining the two is always better, and it's always more effective than either dieting or exercising alone to achieve your weight loss goals.
100%.
Of course, if you burn calories with the exercise, say 500 calories a day by doing an hour of aerobics or something a day, and you cut down your calorie intake by 500 calories, there's your 1,000 calorie a day deficit, which will ensure you lose weight reasonably quickly.
Yeah, absolutely. And if we circle back to on the immune front, again, the last year with COVID, it's sort of been like the red wine and Netflix at night. Everyone's staying up a bit later, especially when lockdown was on. And, we've talked about the sleep impacts on immunity, but what about things like alcohol intake, or in the evening, ultra processed food intake is really ramping up when we look at some of the research on late eating. And so snacking on sugars, drinking alcohol late in the evening, how are these things going to be impacting immune function?
Yeah, not good, and not impacting your overall health either. We know that particularly binge drinking, where you have a real good,
maybe a good night,
but it's good, a real a good night, but you've done it through drinking a lot of alcohol. That we know has a negative impact on your immune function. And there's a lot of calories, a lot of hidden calories in these drinks, particularly things like red wine, for example. You get through one bottle of red wine, you've essentially taken on 600 calories of useless calories in terms of what you can use it for.
Doesn't store as glycogen, does it?
It just gets converted to fat, most of it. So and you can't use it as a fuel for exercise. You can't kind of directly burn it up in itself. And it does impair other things like your cognitive function, the way you
REM sleep and all that.
You behave and everything, so you upset your partner and your neighbours and everybody else along with the impact.
Do get a few polyphenols, but
well, you get some polyphenols, but in that case, you want your polyphenols, then you
small
drink
doses.
Non-alcoholic versions of beer or wine. Not quite the same taste, I know, but a lot better for you health-wise.
Yeah. 100%. Well, listen, Prof, I could pick your brain all day here, but I do appreciate your time. Obviously tremendous. You do a football nutrition book coming out. You've had a big impact on us at Canada Basketball in terms of supporting our players and teams with their immune function over some cold, harsh Canadian winters and lots of travel. Where can people stay connected with yourself and then pick up some of the new books and past books as well?
Well, I'm reasonably active on Twitter. So people can find me there. I'm also on LinkedIn, which is sort of a more sort of professional, if you like, sort of social media type of platform. Those are the two ones that I normally use the most. My email address isn't a secret. Anybody can find that on the Loughborough University website if they want to directly contact me, or they can direct message me on Twitter, for example, or on LinkedIn if you happen to be on that. I'm available for those. I tend not to use Facebook as a communication thing. That's something I leave to my wife and my kids.
Tremendous. Actually, one last question before we go, Prof. Yeah, in terms of the evolution of research around exercise and immunology, particularly as it relates to sport, are there certain avenues? What areas do you see in the next sort of 3 or 5 years or 10 years even that could be on the horizon?
I think there's an increasing interest in the impact that both exercise and diet has on your gut microbiota, and what the interactions are with your gut microbiota, and not only your immune system but also your brain. It seems kind of a happy gut. You've heard the term gut feeling. Yeah. Well, it's probably a real thing. There is actually, a chemical and nervous connection from the cells in your gut to the brain, and that's influenced by the composition, abundance, diversity of that microbial population you've got sort of living symbiotically with you. And when your gut microbiota is in the best state, then it's actually positively helping your health. If you ignore it and eat not enough fiber, not enough protein, you're not feeding those gut bacteria enough, and you can get other ones developing that you really don't want to be there. And then it seems to also influence your ability to actually put on weight when you overeat a high fat diet and things like that. There's lots of interactions going on there. So I think there's a lot of research to be done yet on how we can optimize the gut microbiota and its interaction with our immune system, and also, as I say, with our brains, where it can influence things like mood, sleep quality, and that kind of thing as well.
Tremendous. Well, once again, I appreciate the time, Prof. And look forward to reading more in the new year.
Okay, that'd be great. Nice to speak to you, Marc.
You too. Take care.
Bye-bye.